Hi everyone, welcome back to the channel. In today's video, we'll cover how to extend the Borsh package to define new types which are not supported in the standard Dart Borsh package. Surprisingly, I found that the 32-bit floating point number is just not supported. We will also look at how to work around some limitations with some type conversions between Dart and JavaScript. So JavaScript doesn't have support for 64-bit, for instance, unsigned integers. So we will look into that problem in the hope that maybe if you do find some issues with your JavaScript types, you may basically use similar techniques to the one that I'm going to show you today to overcome those challenges. Um, Before we start, if you do learn something new today in this video, please drop a like, subscribe to the channel so that other people can find this content as easily as you did. And also hit the notification bell so that you can be notified when I post my next video, which, by the way, it's going to be an interesting one because it's one about creating a new Solana token, but I'll talk more about that at the end of this video. So with that out of the way, let's just get started and jump right in. All right, so creating a new Borsh type, which is, I called it BF32, and you'll see in a minute why, but this is basically the terminology that the Borsh annotation package basically uses for their types. So BF, basically it's floating point numbers, 32-bit or 4-byte floating point numbers. So I'm going to basically create this type because, again, as I said in the beginning, it wasn't available in the standard type definitions, which is a little bit odd because the floating point number should really be there. All right, so let's get started by looking at the code that I have here, and ignore this part now for a second, just focus on this one for now. As you can see, obviously we are using the Borsh annotations.dart package, and the other one is the Solana.dart. But if you remember this from our previous conversation, I think it was on the previous video that I was talking about, so Borsh encoding. So obviously, Borsh encoding is a super optimized, very efficient binary format that is used by the Solana blockchain. Similar to, I mentioned in the previous video, for those of you that are familiar with protocol buffers, Borsh encoded is kind of a similar format, in the same way that it's like a binary format, super optimized. This package, again, in the previous video, please take a look at that video if you want to have more details on the whole sort of how to set up Borsh and the types of commands that you can use to generate these files. So as you can see, this is the standard definition of a class that is annotated with the Borsh annotations to really facilitate the conversion into the serialized, super optimized sort of binary encoded sort of Borsh format. And any class that you have defined in your DApp that is a class that is going to be either going into Solana to store in a Solana data account, or you're going to read something from Solana and you're going to deserialize that data from that binary format into a data or into an object in your DApp that you can use to maybe display something on the screen for the user. In either way, you're going to need to use these. Well, at least if you use these, it greatly simplifies the serialization and deserialization into this Borsh format. And so I'm not going to cover today in this video, because that was covered in the last video, the whole, why things are defined in this way. But the point being, and this is where I want to call out your attention to. So this is an example of a class that I have in my DApp, the selected product class. And what this does is it basically contains a list. In the application, I have a list um, of selected products. And the selected product is basically this type here, which basically contains a product ID, a quantity, a weight, a unit weight of the product, and the unit price. It doesn't matter what you have in here. This is just an example. But what you can see here is these types. These are the types that I want you to pay attention to. So the BF hue 32. So this is an integer of 32 bits. So these ones here were already available in the Borsh annotation. So I didn't need to define the BU32. So that's fine. The one that was missing is this BF32, and now you kind of start understanding why I called it that in this way, because to kind of continue sort of the same terminology that was already existing in the package. So they called it BU32, and I called this one BFF, for floating point 32, which is equivalent, as you can see here, to the double type in Dart. So int converts into a BU32, and double converts into a BF32. And BF32, as I said multiple times already, was the type that was missing, that I had to define this type because it didn't exist. So the other thing, I'll show you obviously in a few minutes how I define this type, of course. The other thing, but before we do that, let's just cover the other two things in here. So when we define this class, these two are super important, of course, because one is the from Borsh, so it deserializes the data from the binary format into this class in memory, of course. So this it receives the binary data here in the argument, and it basically returns this selected product in a usable format by the application, so that you can read from it. And then the same thing goes for the writing, the to Borsh. So this is the serialization into the binary format that we're going to send to Solana. And as you can see, it creates an extended binary writer. So basically, these two, extended binary reader and extended binary writer, I had to create them as well. So I'll show you again what that looks like. And I guess the key point here is that you can see that the extended binary writer, what it's doing is it's creating the each of the each of these fields, and it's serializing them into the buffer, as you can see, and in this order, because the order is important. You need to do them in the right order that you have defined, and this order also, by the way, matches the order that is defined in the Solana program, in your smart contract. So there is also a selected product sort of struct, let's put it like that, in the Rust code, where things are defined exactly in this order as well. So as I mentioned in my last video, the order is really important. And so you can see that the writer then writes all of this stuff. So this is one of the things you need to do. But basically, so you need to define the new type, BF32 in this case, and you need to define the the extended binary writer and the extended binary reader. So let's see what all of these things are. So now let's look at the right-hand side here. So this is the BF32 type, the new type that I had to create, which did not exist. And as you can see here, it extends an existing B-type class, which is a generic type. And now I'm saying, okay, so this is going to be converting from double into this type. And so the B-type class already exists. I believe this one is in the Borsh annotation package again. And you have to override these two methods, the write and the read. And so yeah, so in this case, I'll show you now. I'll show you in a minute or two the definition of. So you have to define these extended binary readers and writers. So these we have to create, as I said already a few times. And very simple, right? So in one case, in the reader, you get the buffer in the argument, and then you read from the buffer. And in the writer, it's the opposite. You basically get um, the buffer and the value that you're going to write into the buffer, and then you call the write f32 into there. And again, these two methods, the read f32 and write f32, are effectively methods that we define when we define these two classes. So let's look at the definition of the extended binary writer and reader. Okay, so let's start with the reader, which is the simpler one, and then I'll go into the writer. So the reader, quite simply, again, it extends a pre-existing class. So I didn't have to define binary reader. It was already there. Again, I believe this was part of the Borsh package. And as you can see, it receives a buffer. And effectively, this is the read f32. So this is the one that you saw just a few seconds ago that gets called. And effectively, this is converted into a byte data, an object of type byte data. And then this byte data, in that byte data, you can call get float32. So this get float32, I didn't have to define it. It was already there. So I had to basically just call get float32 from that certain offset that is, the offset again is part of this binary reader, so you don't have to worry about it because this is already defined. So you just have to use it. And then endian little, again, this is the format that is used in Solana, so you have to really pay attention to that. So that's the way that you need to define it as. And then offset +4, because again, you increase, as I said in the comment here, you increase the offset by 4 because it's a 32-bit float, which effectively is 4 bytes. So you keep moving the offset as you continue reading, and then you return the value. So very, very simple definition of an extended binary reader. And now let's look at the writer, which is a little bit more complex, but not too difficult to understand. So to write, you have to first understand whether the buffer is going to need some resizing or not. So if and this is so it calls this maybe resize, but if there is enough space, there is no need to resize, and therefore it basically just calls the buff set float. So again, I didn't have to define this set float32; it already exists. So you basically just call set float32, and you pass the information, the value that you're going to write into the buffer in there, and just do length plus equal 4, basically saying that the buffer is now 4 bytes larger because you just wrote into it. But this may be resized again. I don't want to spend too long on this, but the logic is quite simple. So um, you have these two variables here that you need to pay attention. So the length in bytes gives the buffer current total capacity, and the length represents how many bytes are filled with data, like that have actual data inside it. And what you're doing with this logic here is basically saying if fewer than 16 bytes remain available, the buffer is considered full enough, in which case you need to trigger a resize of the buffer. And a new buffer then is, if this condition is obviously met, or not met in this case, because there isn't enough space, then you need to resize. And when you do resize, a new buffer basically is created that includes the existing data that you already had in there, plus the initial length more bytes, which is what is defined here, which is 1024. So effectively, that's the size that the buffer grows, grows for an additional 1024 bytes. And this approach basically, if you can think about it, it's an approach that is there to minimize the frequency of resizing operations. And this effectively improves efficiency, especially when you're writing, many small data chunks. You don't want to be triggering this resize like too frequently because it's a costly operation. So for efficiency reasons, whenever you want to resize, you basically just resize for a large enough chunk so that you don't have to do this very often. So that's really it. That's all I needed to basically say around creating a new type, a new Borsh type that doesn't exist in the default sort of standard Borsh annotation package. So I was actually surprised that the floating point type, at least the 32-bit one, was not available. So by all means, guys, if you want to use this, feel free to copy the code straight from here. It works. It's very, very simple, and it does the trick. Right. The second point that I wanted to cover today, and then that's the end of the video. Again, I'm trying these shorter, sort of smaller videos, more dense with information still, but a lot less information, so that it becomes a little bit more digestible. Hopefully you like this format a little bit more. It doesn't mean that I won't do any more hour long or hour plus long videos. But in the ones that I can, chunk it up in smaller bits, I will do it. But others, they may take as long. So, right, so let's talk about the JavaScript limitations. So, let's look at this one here. So when I was, and this came up, as you can see here in this code. So this is I took a sort of a screenshot of the one of the functions that I have in the DApp that basically tries to create a purchase order metadata in the Solana smart contract. And as you can see here, I'm trying to create the purchase order seeds for this. And in the seeds, there is an element there, which is the number of the last order that was created. So if you recall from past videos, I have this admin sort of data structure in the Solana smart contract, which it's like a counter for various statistical sort of numbers that the application uses, and one of which is how many purchase orders are logged in the system. And the purchase order, I created it in the Solana smart contract as an unsigned int of 64 bits, which is quite a large um, quite a large. So when and that's not a problem for Dart itself. So Dart supports these types of numbers. It's called a big int. As you can see here, it's this type is effectively the same as the U64. The issue arises when you compile. So because obviously I'm using Flutter to cover both web, iOS, and Android, when this code runs on mobile, it's fine. Mobile doesn't have a problem because Dart is compiled to the native um, iOS and Android sort of platforms, which do support um, this type. The issue arises when I do Flutter build web and I try to convert the Dart code. So basically what that does is it converts the Dart code into JavaScript. And as you can see here, before this code that you see here in the speeds, I had a code that was kind of similar to this one here. So it was trying to use the buffer object to convert the big int, this last order big int, to convert it straight into the binary format that was going to into the bytes basically that were going to be part of the seeds that we were going to use. And so that when I tried to compile this for web, it basically gave me this error that you see here: unsupported operation uint64 accessor not supported by Dart2.js. So if you see this, this is how you fix the problem. So so this is basically an error that occurs, as I said, when you try to do the Flutter build web situation. And we're just reading here from my notes. JavaScript's array buffer is limited to 32-bit integers, which causes issues when you attempt to use uint64 in the web context. So you can work around this limitation by manually handling 64-bit integers in Dart for web by splitting them into two 32-bit integers, which is what I'm doing here with the low bits and the high bits. So this approach works well in both Dart, mobile, and web. So this code, basically, I don't have to change the code in any way, shape, or form. Now this code actually works both for web and mobile. Again, if I were just using Flutter for mobile and ignoring the web component, then I wouldn't even need to do any of this. The only reason, again, as I said, that I need to do this is because in my project, I want this code base to be usable also for web, not just mobile. If your project only uses mobile, then you don't care any of this. But obviously, presumably, if you're using Flutter, you probably want to cover as many bases as possible, as many platforms as possible. So if you're using Flutter for web as well, then you have to worry about this. So some types obviously don't convert well to JavaScript, and this is why you need to do this. One other aspect which is very important here is that the sequence of writing into the buffer, you first write the low bits and then you write the high bits, and this aligns with the little Indian order or format which Solana expects to receive. And this is basically the correct way to construct the seed for this Solana format. So that's that. The way you convert these, I could spend another 10 minutes explaining this, but I think this is out of the scope of this video. But if there is plenty of documentation online if you want to figure out how this works. So I'm not going to go into that detail now. But feel free to drop a comment actually on the comment section of this video if you do want some help with this. I can help you and reply offline on how to figure out how to do this. But as I said, there is plenty of documentation online on how to convert, how to split basically a 64-bit into two halves of 32 bits. All right, so in conclusion, we got to the end of the video. We've covered how to create a new Borsh type, which is the floating point 32, the so-called BF32, which did not exist in the package in the default standard Borsh package. And we also looked at the workaround for JavaScript limitations. In the next video, we'll explore the exciting topic of creating your own token in Solana. How about that? That's exciting, isn't it? This will be obviously a fundamental part, at least for me. The reason I wanted to do it was not just because I want to, it's fun to know how to create a new Solana token, which is all the rage today. So everyone is, pump.fun and all those things are creating tokens like crazy. But first I wanted to know how to create the token just using the Solana tooling, not some random application that is there for people that don't really use the Solana tools. So there were two ways, and I'll talk about this in that next video, of creating the token. One via the CLI, another one programmatically. But anyway, the point is, we'll be talking about tokens and creating that token. And in that video, I'll explain why I wanted to create the token. So thank you very much for following along. I hope the presentation gave you that sort of more clear understanding of how to deal with unsupported types in the Borsh standard package and how to overcome those JavaScript limitations. As always, feel free to reach out with any questions or feedback in the comment section below. I will be more than happy to point you in the right direction. If I know the answer, I'll definitely help out. And stay tuned for more updates. And don't forget, as I said in the very beginning, to like, subscribe, and hit the notification bell. Stay empowered, stay decentralized. Thank you very much. Goodbye.